Now I want to show you how to mathematically model this interlocked FFL network. Okay, let us assume that x1 is always constant. How about this y1? Let us first have this term. So this is a degradation parameter and we have y of I minus 1. And now, what is input for y of 1? We need to find out arrows that go into y1. So there is one arrow here. And that's it, right? So this x1 is the only input. We should have x1 here. And the parameter we call p sub x1, y1. Because the arrow goes from x1 to y1. We have x1 and y1. And we put plus sign here. How about z1? So z1 of I is equal to, again, we need to have this term that represents degradation. So P sub Z1, Z I of minus 1. What are the inputs for Z1? So the arrow is coming here, and there is an inhibition coming here. So we have two inputs, X of 1 and Y of 1. Let's first erase this. We have X1, I minus 1, so which is this one here. And the parameter is px1z1. So this arrow goes from x1 to z1. So we have x1, z1 plus, no, actually minus, because this is inhibition, right? This is activation. So for activation, we have a plus sign. For inhibition, we should have minus sign. So it's minus p y1 z1, y1 of I minus 1, and the derivation which is p z1 z I minus 1. How about x2? Now we should have this degradation term which is p x2 x2 I minus 1. And we have two inputs, x1 and y1. They are both activation. So we have positive x1, x2, because this arrow goes from x1 to x2. We have x1 and x2, x1 I minus 1, and plus this one, p sub y1 x2, y1 I minus 1. Now, how about y2 of I? It should have its own degradation term, which is p sub y2, y2 I minus 1. And how many inputs does y2 have? Only x2. So we have p x2 and y2. And here we have x2 I minus 1. So this equation is for y2. And how about z2? So again, it should have its degradation term, which is p z2, z2 I minus 1. And here, how many inputs does it have? It has this, and this Z2 has two inputs, X2 and Y2. This is activation, and this is inhibition, right? So we have P, X2, Z2, and we have X2, I minus 1. And now this one, that's inhibition. So we put negative sign here, and P, Y2, Z2. So this inhibition goes from Y2, Z2. So it's P, Y2, Z2. And here we have Y2, I minus 1. That's a Z2. And finally, we have this Z3. And there are two inputs. This one and this one. X2 and Y2. So we have Z3. And it is activated by x2 and y2. We have this parameter px2z3 plus py2z3. And we have a degradation term for z3, which is pz3 z3 I minus 1. This is how you mathematically model interlocked FFL. Here we have the code for simulating interlocked feed-for loops. So we have these 7 genes, x1, y1, z1, x2, y2, z2, z3. And we assume x1 protein levels are constant, which is 10. And the initial value for other proteins is 0. And we have the parameter values here, and the difference equations are shown here. Okay, and these lines are just for plotting. And now let us run the code, and this is what we see. So again, we have this purse-like expression for Z1, and after some time delay, we have purse-like expression for Z2, and finally we have Z3 expressed after Z1 and Z2.